Thank you for joining the CLOVIDD project group, which stands for Coronavirus Location, Oxygen Saturation, Verification of Temperature, and Individual Pulse Rate Detection Device, with group members Matreyi Joshi and Stephen Starowitz. Early on in the coronavirus pandemic, there was some literature that surfaced showing that there was the potential for a drop in oxygen saturation levels of a patient without any outward signs of distress or difficulty breathing. As a result of this, we wanted to make a device that was able to detect changes in oxygen saturation, as well as a few other characteristics, aggregate that with anonymous GPS data, and send it to an administrative server for review. We also decided to give the wearer or the patient an opportunity to see when an alert had been sent, and as such included a buzzer and an LED in the device for feedback both visually and auditorily to the wearer. As a part of our project schedule, we initially focused on two main parts. The first being integration of the LoRa transceiver with our microprocessor, and the second being the integration of our sensors and our GPS module with that same microprocessor. As such, our deliverables focused on getting any data at all in the very first part, and in the second part, getting verified data to prove that we were actually reading heart rate, pulse oximetry, and temperatures from a human and not from another creature.
Let us now see how the sensors and the Arduino communicate with the internet. When we place our finger on the heart rate and the temperature sensor, it gives the values to the Arduino, and using a MATLAB code, we send all these values of the heart rate sensor, SpO2 value, the temperature in degree Celsius, degree Fahrenheit, and the GPS to the ThinkSpeak website. Along with the latitude and longitude values, we also get the exact location of the user. So here, for example, we have kept the temperature greater than certain value. We can see that the red light is glowing, as well as the buzzer on our circuit with the LED is also glowing. In this way, we are successful in showing all the sensors value via internet. This concludes our IoT part of the project.
Of our device completion, we were able to share the results that all three of our modules, the GPS, the heart rate and the O2 saturation module, and the non-contact temperature sensor, all provided data. However, we were unable to get the data to be verified data to match with what we expected with a human. Part of this had to do with the fact that the GPS module provides sentences of its data in NMEA format on a UART connection. And as such, sometimes our loop would miss that particular header for that data, and we would go minutes at a time before getting a new fix on the satellites. We found that our pulse rate and our pulse oximetry data showed peaks and valleys that were indistinct, with a human subject sometimes showing heart rates as high as 200 beats per minute when sitting at a desk, and sometimes showing oxygen saturation levels below 50%, which again is unrealistic for a person sitting at a desk. Lastly, our temperature readings, although they were spot on, they were those of a finger and not those of a forehead or an earlobe or anything of the central mass of the body, meaning that we were unable to confirm the internal temperature of the organs based upon this reading. As such, we did have to adjust a few things, and we also were unable to connect our microprocessor to the LoRa transceiver provided by the university. Therefore, we were unable to send it wirelessly to our backend server. As such, and as can be seen in the diagram below our results section, we kept our three sensors, our microprocessor, and our buzzer and our LED. However, we had to dispense with the LoRa transceiver, instead opting for a wired connection to our ThingsWork server via a laptop. As such, we were able to conclude that the quality of the data is the most important portion of this project, and that we were not able to achieve values consistent with quality data, and as such, this device is not ready for production. We also note that the looping of the particular sensor device data needs to be optimized better, either through multi-threading, multi-core architecture, or through a different use of interrupts. And we also note that we need to have a better packaging mechanism for data to transmit over the LoRa transceiver or through a hardwired connection to a different type of transceiver. We leave open for future work the possibility of using either a different GPS sensor or one that accepts a hardware interrupt to allow polling of the data as needed. We acknowledge that the algorithms for smoothing and detection of peaks with the heart rate and the pulse oximeter need to be readjusted, and as such, we would require additional development time there. We also note that the selection of a microprocessor capable of interfacing with the LoRa transceiver makes this a true IoT device as opposed to just a brief prototype device. And we also note that because our temperature sensor was capturing a finger temperature, that we need to move that temperature to the central mass of the person or to the forehead to provide a more accurate internal organ temperature. Thank you so much for watching, and we look forward to answering your questions.